Hello, everyone. Thank you for having me here tonight. As introduced, my name is Dave Hughes, and I'm the CTO at a company named Stelia. Stelia originally started out as a research project in networking products or networking technology before being productized into a commercial product following the GPT sort of boom in late 2022 going into 2023. Today, far more focused on sort of every layer of the AI stack as a whole and seeing how we can take AI as it exists today in various forms and actually take it into applied AI products for enterprises where there will be a measurable return on investment for those companies rather than just a chatbot. Who am I? I have a background in software engineering primarily. Also systems administration, have to learn how to host your product at some point. Most people pick it up then. And along the way, I picked up network engineering out of necessity rather than choice. I am a passionate technologist above all. I'm an open source developer, user and enthusiast. I've been a Linux distro maintainer at one point in my life, maintained parts of the user space technologies upstream. And I still contribute to various things today, mostly just bug fixes whenever I find something that's broken. Normally easier just to provide a patch rather than complain that it's broken. More importantly, I'm a problem solver. I always try and view things as it's a problem that needs solved rather than how can I take someone a solution in search of a problem. Why are we here today? We've got a room full of people who at some point have interacted with AI technologies, maybe tried to build products. I've got a raise of hands of who has tried to build a product in the past 12 months, incorporating AI, whether it's a language model, anything at all. A lot of people in the room, that's good. How many of you have tried either, or I assume most of you are developing in cloud, are you hosting in cloud, are you self-hosting, what's the sort of split? I imagine some people might have GPUs in a machine at home where they play around with. Is that the case? Again, just raise hands. Okay, that's fine. It's fine. Give an answer. Cloud, anything at all. So yeah, for cloud, hands up if you're doing it in cloud. Okay, hands up if you're self-hosting any of this. Doesn't matter whether it's a gaming PC at home, whether it's a beefy 8-way server, whatever. Okay, so still a few people doing that. So sort of state of the union on AI software as we see it today. A few of us, I imagine, would have started out probably 10, 15 years ago, back when it was still machine learning, before it sort of moved into the AI space. I like to say there were sort of two big marker points that sort of brought us here, GPT-3 and then GPT-4. GPT-3 less so. Again, it sort of sparked an interest in a lot of companies, but I think GPT-4 in March 2023, especially when you start tying it to the sums of money that was raised and started getting spent on AI infrastructure, that really started to drive. Lots of new startups in the AI era, whether it's infrastructure providers, whether it's application developers. Hands up in the audience if you have been at a startup that's been born in the past 24 months. Small amount of people. Past 36 months. Okay, so still in that sort of period. That's good. Lots of SMBs and enterprises looking on with intrigue. I've talked to quite a few enterprise customers of an OEM that we're partnered with. And it's always interesting when they say one of the biggest barriers to adoption is that they no longer self-host their own infrastructure. They all migrated to cloud in the past 15, 20 years, mostly AWS, GCP. And most of them aren't necessarily, at least 2023 time, it wasn't necessarily possible to get GPU compute on these platforms as easy as it had to be. There was a real glut of GPUs, but it's being hoarded in the hands of a few, basically. The sort of ensuing gold rush and hype train pulls bias from HPC and traditional cloud computing. Progress is made, problems ensue. Again, lots of people finally get their hands on resources and they start making progress. But as I've found speaking to a lot of companies that we've been working with in the past 12 months, it's quite easy to build a prototype or an MVP, and like if you're self-hosting it on one machine, maybe a couple of GPUs, and it's okay, great. How do we take that to production now? And you have to go out and do your capacity planning and your thinking up front. How many GPUs do I need? How much RAM do I need each GPU? How really developer teams are actually expensive assets? I mean, we're seeing H200s like $40,000 per GPU. It's not cheap. The B200s, B300s, that was getting even more expensive, and the Vera Rubin generation, I mean, we're now looking at, you're not able to actually buy individual components. It's the entire interconnected system or nothing at all. So before you're looking at any of this, if you want to self-host your own kit, it's not going to be an option for a lot of people. So it's going to be, I now need to go and rent that from a hyperscaler. We alluded to the problems with that, with the US-based hyperscalers and offering labeled sovereign products, but not necessarily sovereign in reality. Problems. As I alluded to, the AI arms race led to a shortage of resources. It's, I think, easier, well, for a period last year, it was easier to get your hands on GPUs, but we've seen the prices of H100 rentals increase again. That also plays into the sort of, if I'm an SMB or enterprise and I now see the prices of GPUs going up again, that doesn't necessarily make me buy the GPUs now. That just means I maybe withdraw whatever my participation is going to be. Neoclouds arise to meet demand. Is anyone here not aware of what a neocloud is in comparison to hyperscales? Okay, so neoclouds were the sort of, lots of them came out of the crypto mining industry. There were people who typically had capacities of power and real estate, so-called power shells or powered shells rather than data centers. And they were able to deploy lots of GPUs very, very quickly and lease them large scale to OpenAI, Microsoft, and other hyperscalers who didn't necessarily have data centers that had the high power densities required to host this. Very prominent examples of neoclouds being people like CoreWeave who have done this successfully. Lots of other small examples in Europe. I used to work for a neocloud. I worked for the first ever neocloud as it happens. The other problem is the majority of neoclouds aren't actually cloud service providers. Lots of them deployed resources into a powered shell data center and basically just handed over the keys to the BMC of the machines on a you break, you buy type agreement. That's not a cloud though. Everyone here who's consuming cloud today is used to consuming compute instances like EC2, API-driven elastic infrastructure. You're used to going in, configuring all your IAM functionality, your credentials for your different teams, being able to track billing metrics, all of that sort of stuff. That wasn't necessarily available on these neoclouds. So if you're a business that's consuming entirely cloud product today, could you have went and consumed that product from neoclouds? Arguably not. There were a lot of biases from the HPC cloud computing pulled into the AI world, both good and bad. HPC, some of the biases brought in immediately were that you needed a parallel file system for storage products. And hands up again, has anyone worked in HPC at all at any point in time? Oh, okay. So for all intent and purposes, parallel file systems being able to distribute lots of small files, large files to a large cluster of machines very, very quickly for all intent and purposes. And moving into this AI space, you would have storage vendors making claims, oh, you can't use Ceph, open source storage product in AI clusters because the latency is too high. Lots of varying claims. I've got differing opinions, but unless you're running it like a cluster of like 300,000 GPUs like XAI or something or other, I find it highly unlikely that you're going to be bottlenecked by Ceph running on Flash. As we got into this point, startups rapidly started prototyping POCs, MVPs. Again, like I alluded to, startups were probably more likely to go out and consume small bits of product from neo clouds, or even just providers like Vultr, Voltage Park, fluid stack. They didn't actually own GPUs. All they did was develop a sort of software stack that allowed them to go out, find idle systems, drop their software on it, and offer it publicly. And another good example being RunPod. Does anyone use systems like RunPod or anything else for trying out AI products? Raise your hands if you've been doing it. Okay, a few of you, that's good. So you're familiar with the sort of concept where you can find short-term GPU rentals for playing around with things. So that's typically where most people got to with their prototypes and MVPs. But again, like I alluded to, when you actually come to doing capacity planning to take that to production, and then you even start thinking about how do you scale that across geographical regions, that then becomes challenging because you no longer just need GPUs in a fixed location, you now need them in East Coast US, West Coast US, Central Europe, Northern Europe, so on and so forth. SMBs and enterprise still looking on. Most of them have been burned in some form in the past with cloud migrations and other things. And they've, again, one of the most common things that we heard when we were working with these enterprise customers of an OEM partner, I want to do this, but I don't know how. I don't have the infrastructure to try it myself. My internal company policies don't allow me just to go out and rent GPUs short term from people like RunPod because they're maybe not certified. Lots of other things like that. Frontier model builders aside, most of these never scaled above MVP or POC. Oh, you asking a question or raising your hand?
Quick question.
Sure.
So thank you for your presentation so far. Quite informative. I just want to go back to your point about neoclouds.
Yes.
The majority are not actually cloud service providers. So obviously you are an insider, so you know how to recognize the bad apples from the good ones. As a non-insider who doesn't want to get burned, so how can I recognize?
We do questions at the end. I think that's what we're.
Yeah,
you're going to say?
At the end, please.
I'll come back to you first, though. Don't worry.
Okay, that's fine. Thank you.
So yeah, frontier model builders aside, most of these never scale beyond MVP or POC. So I'm going to get to the point of talking about my experience doing this. So I started out originally, I had exposure and experience in traditional high performance computing, starting out as CPU compute, but moving into early stage GPU compute. So I will talk about my experience both from the position. I've been quite fortunate. I've been in the position where I've had developer teams who actually had to develop products that were based around machine learning and AI. And I've also been in the position of having to host it myself. So it was interesting to see different sort of sides of it. So as I alluded to, I started off early HPC and moved on a bit. And about 10 years ago, plus or minus a couple of years, I was working at an ad tech and marketing tech company. We self-hosted all of our own infrastructure. It was a large infrastructure, and like most companies like that, like Google, for example, we used internal like workload scheduling and management software similar to cloud computing to get the most efficient utilization of all the servers. And again, like cloud computing, you can move up your instances are all virtual machine backed. You can move them between machines as different teams want to move it to different regions. Basically, just again, cloud computing as we know it today, elastic API-driven infrastructure. However, the problem is when we got to the point of discussing, we want to start building machine learning-based products for ad fraud and in that space. We had also teams who were data scientists who wanted to do accelerated workloads. So as I was director of engineering at the time, I started getting the requests. We need GPUs. And it's like, okay, can we define GPUs? Do you need NVIDIA? Do you need AMD? Well, I don't know. So you start off, you give people some NVIDIA GPUs. And it's like, okay, how much VRAM do you need? Oh, I don't know either. Now, I didn't have a massive amount of experience at this point in time. So it started out where we basically started putting I think we had a handful of like 8 servers, and we started putting consumer grade GPUs into them, NVIDIA GTX 1080 Ti, if anyone was into gaming GPUs. And it was an interesting learning experience as you started to see some teams, their products and what the characteristics of that product was. It would require a lot more VRAM than other teams. And then, of course, the inevitable question comes from management. Oh, That GPU has 11 gigabytes of VRAM, but the team's only using half of the resource. Can we not just have them share the GPU with another team? Not necessarily the case, and this is the problem. So if we look at how this stuff works today, in most traditional cloud computing environments, the compute instances are backed by virtual machines. Now, when you're wanting to oversubscribe CPU cores, you can quite easily do that with tenants and CPU compute. In GPUs, it's physical hardware, and you're having to attach the physical GPU and bind it to that customer's compute instance, the virtual machine. So when you're thinking of two of the management question posed to me, can they share the GPU? Not really, because one team's compute instance has the GPU attached to it. Now, there are technologies for tackling this. I'll come to those in a bit. But the biggest barrier to that was one GPU equals one compute instance. And it's a bit of they're tied together, unfortunately. This then came to the hosting part again. So the more we started adopting and developing these types of products, the more teams started requesting them. And before you knew it, we had 2 GPUs in this machine, 1 GPU in this machine, 4 GPUs in this machine. And it gets a bit ridiculous because there's no uniformity. It's not really tracked that well. And again, it comes back to the original cloud computing concept. Why were we using that sort of cloud computing infrastructure-based product to begin with? It was to make sure that we were getting the maximum asset utilization of all the 2,000, 3,000, 4,000 servers that we had in the company. Because otherwise, it's difficult to say to someone, oh yeah, we've got 4,000 servers, but the average server is only at 60% utilization. And then the inevitable question comes from finance, can we just get rid of 1/3 of the servers? Not necessarily that simple. So that was a big problem I had. And then as I moved on from that company and we got into the sort of GPT boom and revolution and all the other nice stuff, I ended up working at a so-called neocloud. I did not join this company at the beginning. I had joined a little bit later on, but like many, they were a former cryptocurrency mining company. They had like 500,000 GPUs left over from the crypto mining business. And with the collapse in the price of crypto at that point in time, they decided, oh, can we build a GPU accelerated cloud? But when I'd said that not all neoclouds were necessarily cloud service providers, they'd actually set out to build something equivalent in functionality to EC2, where you could create compute instances via an API. You could choose to provide your own compute instance image via the API, whether you wanted Ubuntu, whether you wanted Debian. You could specify it all via the API, just like with AWS. You could go in and create your company's organization within the IAM functionality. You could add your billing information. You could create the managers who were responsible for the billing. You could specify different teams. You could specify the leaders of those teams and who could manage who. It was an actual cloud. And that's what attracted me to joining that company at that time, because the big challenge they had was, can we bring the cloud infrastructure that we know and love, but with the option of GPU acceleration, which many people were starting to want at that point. So the challenge then was, it was really, really, really difficult again to get GPUs that were, we tried a lot of AMD GPUs at that point in time. We were plagued by the notorious, I don't know if anyone has, raise your hands if you've got experience with virtualizing GPUs. Anyone at all? So when attaching the hardware to the virtual machine, you can often be hit by what's called a PCID reset bug. And basically the GPU itself will get stuck, so to speak, and you need to reboot the instance entirely, sometimes even the machine, to make that GPU available again. So a lot of effort had been spent working on AMD GPUs at that point in time, which was plagued with that bug. We ended up working with NVIDIA. We got it working. And that was sort of seen as the fastest path to market at that point in time. Most people familiar with like NVIDIA's CUDA software. For everyone developing and using the GPUs directly, I'm assuming you're using CUDA or the NVIDIA software in some form. Again, show of hands. Okay, good. So we had started developing that. And as we took this product to market, again, we done the same sort of EC2 functionality. You spun up a compute instance, you were able to SSH in. and we provided the images pre-configured with all the runtime libraries and software needed. As we got to this point, we started learning that it was quite interesting that different people had different requirements. We had some customers that were wanting very specific NVIDIA driver versions because they had observed a performance degradation on the newer version. And it was interesting to see some customers at that time actually tracking things like that. And that comes back to my experience now, where it's like, if you're just buying a server with 8 GPUs in it and you throw Kubernetes on it and you try and make people share the system that way, they're all still sharing the same driver stack. So you can't necessarily even say this workload's better with this driver version, thus we must pin the driver version and keep it frozen here for this application. Of course, there'll be potential security issues later in life when that driver version is never updated, like anything else. But again, from a hosting perspective, this is the challenges that you face. If I'm the hoster and someone starts nagging me saying, hey, my product's performance has just went down by 15%, can I now start paying you 15% less? That's not very well received. What could the future of elastic infrastructure look like? So I'm going to split this into two sections, the first of which is HPC. I mentioned before, a lot of biases have been brought in from the traditional HPC world. We need those, good and bad, but I would say the overall lessons learned from HPC need to be brought in to AI. That is, namely, tried and tested holistic systems thinking proven in HPC. What I mean by this, in high-performance computing, when clusters, the infrastructure is fairly static in nature, unlike the elastic side of cloud computing. You design a cluster, it's designed upfront because all the individual systems are interconnected via a massive number of switches. You have to plan that capacity upfront, and that cluster will likely stay the same size its entire life cycle, 3 to 5 years historically, maybe even longer. That forced people to actually consider, where do I need to be in 5 years' time at the very beginning? And I found a lot of people have not done that in the AI world. They've developed something, they've tried to say, okay, how do I take it to market? And then figured out that their bottleneck's by a single RMQ that basically craps out at 50,000 messages. Not ideal when you want that to be your single point of data ingestion. Cloud computing version 2, I'm going to term it. We need the same elastic infrastructure that we've come to know and love. It's incredibly developer friendly. Most people are used to being able to create compute instances via an API, being able to manage their entire infrastructure via Terraform and other infrastructure as code providers. It's brought massive efficiencies and gains to, whereas in the past, we again would say, oh, we've got a server fleet of 200, 300, maybe even thousands of servers, but they're all sitting at varying levels of efficiency or utilization. Whereas in the cloud computing model, if you're self-hosting that, it's quite easy to say, okay, that's the utilization levels, we can just migrate some of the virtual machines machine to machine, and then retire the old ones and make it more compact, drive up the asset utilization. I keep saying that word asset utilization. I'll come to that in my closing remarks. One of the big things, data mobility is non-negotiable in the AI world. Everyone here, I assume, is aware of data transfer fees, AWS, GCP. Basically, if you want to move a petabyte of data, you're going to be running up quite a few credit card bills. Anyone else here been stung by data transfer fees that they didn't actually know about? Again, raise your hands. Oh, it's more common than you think. You end up, someone leaves an EC2 instance on, and before you know it, something's copied data out and 15 grand down maybe. It's not easy. But with AI, we're in this interesting world where data is going to have to move between locations, especially as we move beyond just training models, but we start looking at inferencing. Inferencing is what people think of when we talk about consumers of AI, like agents, maybe fine-tuning an open source model using custom data sets. That's all got to be done at the edge rather than in these massive clusters of GPUs in the Arctic Circle or wherever else where consumers don't actually need them. So if we start to think, if we needed inferencing in the UK, they'd normally be deployed in the data centers of London, whether it's the Docklands, whether it's Slough nearby, maybe further up north. But you're going to have to move your data in and out of these sites. If you've been training a model, if you're into that sort of thing, you're going to have to move lots of or mass amounts of data into that site. Continue going through your model training runs. You're going to have to do your incremental backups, copying data out of that site. Then you move on to inferencing. You're going to have to move data out again. Under traditional cloud computing, this becomes, I'm not even going to say heinously expensive, it's actually prohibitive to doing business. So data mobility is a big thing that Stelia has been talking about since early in its sort of network focus days. But we're still a big believer that data needs to be mobile in the new cloud world of AI. It's going to be a lot more distributed in cloud computing V1. Hands up if you're aware or familiar with US East 1 in AWS. I think everyone knows about it. Every time someone sneezes in Ashburn, servers go offline. Happened quite a few times recently, half the internet went down. Yeah, that's not going to work with AI. It's going to have to be far more distributed, especially as we start to think how many GPUs can you get in a single data center. It becomes a bit of a laughing game at that point. That's not even considering, again, the concept of inferencing has latency requirements and it's going to have to be deployed in metro areas rather than in just massive silos. High-performance computing technologies is going to have to be introduced. If we look at traditional AWS, the systems themselves, while they all sat on the same network to a degree, they were not interconnected in the same way that these cluster technologies are, meaning that every system in the cluster can speak to the other one via the lowest amount of network hops possible. This brings massive challenges because, again, we talked about the static nature of high-performance computing clusters and GPU clusters. If you have to define that up front, it's completely opposite of ideals of what elastic cloud computing infrastructure is today. So that brings you to the point where you're basically having to say, okay, if I'm a provider, I'm going to deploy a massive number of GPUs, but the consumers of those might only be consuming 2 GPUs, maybe 4, maybe 6. That's, again, a difficult position to host from. Key takeaways from today. I would like everyone to stay curious, keep rapidly prototyping, exploring new things. It's absolutely required. I would try and urge everyone to think what big looks like at an early stage, whether that's large amounts of data that may or may not be getting copied in and out of US East 1 and you getting hit with data transfer fees. It might be the example customer that I mentioned who had a single RMQ that was going to crap out at 50,000 messages and absolutely not host their workloads worldwide. Thinking holistically, again, from the HPC world, start thinking about the full system of, okay, if I'm running this, what's my data ingestion going to look like? Where's that data going to sit? Is it, if it's a sovereign system, is it going to be encrypted at rest? All these things have to be considered. Don't try and retrofit it afterwards. I've seen more than a few AI sort of MVPs and POCs that have had to go back to the drawing board after raising funds. If you're a startup and you've went out and raised funds based on a preconceived notion or MVP, and then you have to go back to your investors and tell them that it's not actually fit for purpose, it's not an ideal position to be in. Issues with software, thinking beyond the immediate code base. Sort of a software engineering 101, but I think as engineers we're very often victim to having tunnel vision on issues. And we will spend hours looking at something where it's later very obvious what the problem was in hindsight, but a classic, you can't see the wood from the trees. Profit. Something I mentioned earlier, asset utilization. These things cost massive amounts of money. If you're deploying GPUs or you're consuming GPUs in any way, people are going, whoever your investors are, your shareholders, doesn't matter whether you're a publicly owned company, whatever. If you're telling them you're spending this sum of money on GPUs, they're going to want to know exactly what's coming out of it. I'm a passionate technologist. I said that at the start. I love this technology, but it's imperative that we actually demonstrate ROI on it. Otherwise, it's going to remain firmly in hobby territory rather than going out and being revolutionary like the internet. Again, the internet survived the dot-com busts or bubble bursting because guess what? It was better than fax and telephone. It actually solved problems. So I think if we can do the same with AI, we're going to be in a much better position. But that is actually the difficult challenge now. These things are only getting more expensive. I think, hands up if you're building a PC and you're unfortunate enough to be buying RAM right now. Prices of RAM going up 33, 40%. I bought a 64 gig of RAM kit 12, 18 months ago for about 300 quid. I could sell it on eBay for 1,200 quid just now. And it's even worse. I've seen cases in the market where customers had already went out and done their capacity planning in Q4 last year. They had orders lined up to go and buy GPUs, and they came back after Christmas. Oh yeah, the prices have gone up by 40%. It's not going to be an easy market to do business in, so we're going to have to get to a point where we can focus heavily on how we make the GPU consumption more efficient. One of the things or technologies I mentioned earlier that I was going to return to at the end, I mentioned the sort of tied nature to a virtual machine. The technologies I mentioned or alluded to were vGPU, meaning virtual GPU, and MIG. For sake of ease, I'll focus on NVIDIA GPUs only right now. The theory is, or behind these technologies is, you can slice a GPU 1, 2, 4, or 8 ways. So if you've got a H200 today that's got 140 odd gigs of VRAM and you slice it 8 ways, each of those slices is going to get its own 16 gig VRAM. Theoretically, instead of attaching a single GPU to a compute instance, you could take that single GPU and you could assign each slice of it to a compute instance, meaning instead of a GPU now being bound to one team's compute instance, it's now being shared amongst 8 teams. Technologies like that are where we need to go. We're going to have this cloud infrastructure model and the same elastic consumption model that everyone knows. It's not there yet, and unfortunately, each GPU vendor wants to do their own implementation. Again, classic not invented here syndrome. But you've effectively got 3 competing implementations of this now. So that's massively challenging from, again, both I want to consume this, but I also want to host it. I don't know which way is going to win. I think that we will eventually reach the same point as we did with original cloud computing, where the resource consumption gets massively more efficient than it is now. Questions? Man at the back.
Hi there, thank you for your talk. So first question, how can I check that a Meetup has a genuine cloud platform so I don't get my fingers burned? And second question, should I be using ChatGPT to work out the best data transfer rates to accept? So I know I'm getting a good deal. Over to you, thank you.
I mean, language models are prone to hallucination, so they can sometimes tell you the truth, but ironically, they're quite human-like and they'll never admit they're wrong and they'll just go off on a tangent instead, which is quite fun. So I don't ask models that type of question, so I can't talk to the quality of the answers, unfortunately, but I can say that my experience with ChatGPT is sometimes I get really, really accurate answers and sometimes it's way off. So in terms of your question about how do you tell a sort of real cloud service provider from again, just renting out the bare metal, so to speak, like AWS, you'll sort of configure all your organizational details up front, organization name, billing details, teams, and that's all there for your consumption of the cloud infrastructure. You'll be able to create the machines yourself via an API. You'll be able to specify how many cores you want. You'll be able to specify the RAM capacity. You'll be able to maybe even specify which operating system you mean. Like if you're using Linux, you might want Ubuntu, you might want Debian, whatever. You'll get that choice. Whereas if you're just been handed over the keys, they'll tell you, by the way, here's the BMC password, here's some. They'll ask you probably up front for your SSH keys so they can copy them into the image manually rather than you provisioning that via an API. So that's the sort of real giveaway there. Is that good?
Yeah, thank you.
My man here. Well, not destroy stuff.
At the moment, at in this production, how and it's let's say it's utilized in the cloud. What sort of if the data is very sensitive, how do you place guardrails within the cloud, or how do you secure it?
So this is an interesting question. It's something that actually came up fairly recently. People have talked about the nature of sort of confidential computing and how you keep this information safe. So I'm not going to look at the sort of guardrails on a model level. I'll look at what can be done on an infrastructure level. Steve mentioned this at the very beginning in terms of, again, sovereign tokens not going to the US. Big concern right now. Hands up if you're aware of the messaging app Signal, for example. So the founder of Signal recently came out with a plan for a so-called confidential compute or inferencing system where there'll be a level of, it says end-to-end encryption, it's not by definition. In reality, hands up if you're aware of what trusted execution environments are in CPUs. Anyone? So this is baked into the silicon of, like, AMD has the so-called secure enclaves or enclaves, however you want to pronounce it. And the theory here is that if you're a customer and you're running a compute instance that's bound by a virtual machine, the host cannot see what's going on inside that virtual machine. That's the theory behind it. But the reality is that you're offloading the trust to the trusted execution environment, basically the silicon vendor, AMD, Intel, as we know, US-based companies. So if you don't trust sending your tokens to the US, do you trust a CPU vendor from the US? Not to mention that the secure enclave technology has been exploited 2, 3, 4, 5 times. So I really don't think that's self-hosting. You have to go out and get your own stuff. But again, the problems with this is if you're looking at the average server with NVIDIA H100, H200 in it, these machines are pulling like 12.5 kilowatts of electricity, and they're incredibly loud. And this comes back to the point of people historically have thought of the edge as being data centers, and I believe with AI, we're more going to see the edge being people's offices and homes, where, again, anyone familiar with things like people doing inferencing and running models in the Mac Studio, for example? Good examples. NVIDIA released a little DGX Spark recently. Lots of little examples of this where it's got enough horsepower that you can run models, but you can plug it into the wall and not worry that you're going to blow out or trip the entire building's power supply. So that's definitely one alternative, but again, it comes with a lot of pitfalls and caveats that you need to be aware of, as I alluded to, and keep doing your upfront capacity planning. No problem. Hand it back.
Given that there's lots of different ways that you can run compute GPU, what would be a good way to determine to get the best value for buck, given that people have got different price points for different technologies, different chipsets, different VRAM? What would be a good way of going and tackling that? I mean, I guess the option is run it everywhere, but that's going to be very expensive way to do that.
So that's a very good question. That brings us back to right now, the industry is focused on a whole as basically wanting to release the biggest and best all the time. It's the equivalent of taking a Ferrari to Tesco to do your shopping on the morning school run. Not really required when a Honda Civic would do the job just as well. If we look at car rental companies, last I looked, Hertz and Enterprise Car were not full of Ferraris. It was mostly Nissans and Honda Civics. Good old workhorses that done the job. My experience of working at a cloud provider with these GPUs, we still had 1080 Ti's from NVIDIA, which were released in 2017, running in production last year, because for some customers, the price point of those GPUs, because they've been paid off years ago, were actually just slightly above the cost of the electricity. So that goes back to when you're trying out your product, you're looking if it's a model and you're looking at the tokenization, the so-called tokenomics of how many dollars per token or how many tokens per dollar am I generating. You might say, actually, that old GPU from 5 or 6 years ago is my sweet spot. I don't need the latest and greatest. Not that NVIDIA or AMD want you to know that, but that might be your experience. And of course, like we alluded to, having the latest and greatest everywhere is not necessarily cost effective in the slightest. Actually prohibitive to business.
I mean, is it the case that many distilled models outperform large models?
Yeah.
And the big area is model distillation, and as you said, edge computing. Like for inference, I need low latency. I don't need a super. I just need very low latency with an optimized distilled model for inference.
Yeah, that's one of the big things that's been found as of late. People I think we're going to see a future where there will be very large parameter models built by frontier model builders. When it comes to actually productizing these into agentic-based products and agentic systems, like we said, the little 7 billion parameter models they pack a punch. They do very, very well. More importantly, you get a lot better throughput on a 7 billion parameter model than you do in a 512 billion parameter model or whatever. So I completely agree with you. I'm a believer in that. I think rather than seeing large general purpose models, I believe we're going to see a massive sort of suite or library of all these little, again, specifically trained agents and models that have a very narrow focus depending on what they're actually targeting. So I'm in full belief and agreement with you. And at that.
You're convinced me to buy a you get anything out.
You'll never see another NVIDIA GPU with 7 years worth of lifetime or relevancy. It'll never happen again.
Well, yeah, so I'm just curious to know, how would I know right now, like from the outset, right, of an old GPU or old hardware, that my use case, my model would essentially like a 7 billion parameter model would run well? Because my assumption right now is like I've got an M1 Mac, but that's my baseline. So I don't know, like any recommendation.
So some of the problems you'll encounter is the fact that a lot of the model or the codes or products that you're running might end up depending on the so-called tensor cores that you find in modern GPUs. They were lacking on like the 1080 Ti, so you're looking at sort of just raw rasterization performance rather than all the offloading to the hardware, tensor cores and everything else. Depending on what you're running, the 1080 Ti might be okay. I find it unlikely, but depending on what it is, you may be okay. But again, this comes back to the point of how do you really know what's good? And it's something we've seen a lot of enterprises struggle with. If they're sitting down saying, okay, I've got a budget of however many hundred millions, which GPU do I? Don't know. They truly don't know. And one of the biggest values we've been able to provide is we've got different GPUs of various shapes and sizes. And as part of our business transformation process with them, we've been able to say, you can try out this range of GPUs and we'll find what actually works for you so that we can inspire confidence in your purchase when it comes to making that decision. One good example is we're working with a company that were very data science focused in nature. They train weather models, and they do a bit of training, a bit of inferencing, and they were coming out of shared high performance computing research, resources in a university in England. So they knew what they were using historically. They had an idea of what they wanted to buy moving out of those. But we were able to say, okay, you can shift your workloads to us, we'll host you. And they were able to say, oh, wow, we're seeing this uplift using this model of GPU, but actually only it tapers off by when we go up to the next version of the GPU, we're only seeing like a 15% increase rather than the 60% uplift that we've seen back here. So that's one of the interesting points of it's not necessarily a complete linearly scaling model by any means. I mean, we're all familiar, if you're playing video games, you're quite familiar with, sure, you can keep increasing the GPU, but your frame per second count will stop going up at some point because you'll become CPU bound at some point in time. Any more questions?
Another question. Oh, thank you. So as someone's thinking about moving from MVP to production, what would be your top 3 tips or pitfalls to keep an eye out for?
Thinking how long you're going to run that agent or model in production, whether you're going to increase to a larger size of parameters, whether you're going to go down in parameters, whether you're going to run more of the smaller ones rather than one larger model. Pardon me. All this comes back to, again, in terms of billions of parameters, everything else, how many of them you run in parallel. That's going to have a knock-on effect on demand on which VRAM capacity you have in the GPU. So and again, I came back to that static nature of this stuff, you have to plan it up front. It's not like traditional CPU compute, you decide, okay, I'll provision the machine and only populate half of the RAM sockets and then go back and add more memory later when I need it, or add more storage disks later when I need it. You can't do that with the GPU unless you replace it in its entirety. So I'd say that's definitely one of the areas you want to absolutely focus on, maybe even over-provision. On the topic of over-provisioning, I've seen it previously where let's say, a GPU cluster had been provisioned with the latest and greatest at that time, 400 gigs networking. Running workloads in the cluster, you could sort of observe the GPU utilization was hovering about 90, 91, 92%. Network was sitting high teens, 17, 18, 19. The bean counters in the organization inevitably start asking questions about why is the network so over provisioned, and they take it out and replace it with 200 G instead. They look at the utilization of the network. It's now sitting at 42. They start patting each other on the back. Good job, guys. We've saved some money, everything else. We've proved that the engineers were wrong. 74. So by moving down the network, you're now making your GPU utilization worse. This comes back to the sort of what, as a host, we sort of observed as a spiky nature of these AI products and workloads, where the resource requirements will jump momentarily. And we've even seen it on the GPU, like GPUs themselves, where I mentioned 12.5 kilowatts being the typical electricity consumption at full load of these systems, but the Hopper generation NVIDIA GPUs were notorious for power spikes, where they'd even spike to 13.5 occasionally under that so-called full load. So I really, really focus on nailing down which parts of the infrastructure are static and need to be defined up front, which can you start off sort of smaller and go back to later on and increase your sort of provision when you need to.
Thank you, David, for sharing your vast experience. I think that was a very good summary on the mainly like sort of the infrastructure aspect, utilizing GPUs, and also from a business perspective, how to work with that. We will have like a 5-minute break, and then we will have we will have a demonstration as well, or yes. Oh, great! So we will have a demo as well. And around 5 minutes break for technical stuff, and then we will start again.
How is the
So I would like you to, first of all, we had some problems. You have is it Chrome OS?
No, just a Mac.
I like your jumper, by the way. I like your jumper.
It's the like,
yes.
The Chrome So I have HDMI here.
Do you have HDMI or you need the?
No, I don't have HDMI.
We had a problem with that. So where's the thing?
This one is not working?
Oh, I think they put the video.
It seems to be
yeah.
Word resolution, but it seems to be working. Or maybe not. I don't know.
We had a problem that no one shared the exact.
Let's try that.
I think it's the other one.
This is network. Sorry. Yeah.
We need you to be on the phone.
Oh, it's the same thing, but actually, I think it is right.
Yeah. Can I just forward the invitation? I will need your email address. We will share with you. I actually got an ID. You joined the meeting. You will present from your laptop, but we will share the screen on this, and this will show the shared screen display.
Okay, that's.
Should I end this one?
No, we can keep this call, so it could be recorded. So it will be in the same recording. So if you tell us the email, we can send it to.
I'm just trying to do some magic here.
Daniela dot. Actually, yeah, let's use my Google. It's just my surname at google.com. Petruzalek at google.com. So you have this picture.
Yeah, it's this one. But you should
Yeah.
send it.
I'm sending it to you now.
Petruzalek.
Too many R's. Yep, I sent it.
So you should have the invitation, and then I joined the Zoom meeting here, and I should see if you share your screen. I will share it here.
Oh, it's a Zoom. It's not a Meet. I don't have Zoom machine.
Can you use Zoom from the browser, or is it blocking it?
That's a very good question. Every time.
Because you should be able to.
Yeah, you should be
This
the
is-
account.
So what you have to do is try to reject the thing, click on again, reject it, so it hides the button for the browser. Sorry, I missed this. And then so how do I just need to make it like full screen. I actually can stop sharing because I don't need to. Yes. So if you record the screen,
Yeah.
you might need to change it.
It's gonna be that.
Yes, yes. Sorry?
Like you see very
Oh, yeah. I prefer Google Meet. Yeah. Yeah. So if you join, we should see it. Yeah, good, okay.
There's it's an annoying delay. It's super big delay.
Yeah, I think it's good. And at least it works.
Yeah, that's perfect.
This would be nasty because there's a huge delay.
What's the delay?
So you see, here.
Can you play with that?
We can if that's the only thing we have.
Because people see what's happening here. So it doesn't have to be synced with your scene.
I know, but then I need to click before I actually see. So I need to predict myself, and even when I'm typing and like coding, this will be okay. Doing a demonstration, this will be horrible. Ah, what can I do?
I think we'll be okay.
Don't you have another cable?
Yeah, so the problem is they all try to connect with the Mac and it didn't work. So it might be something with the firmware of the display. Okay, I'm just going to call people back.
And then your second last slide, like some lines, make sure you understand like that's somewhat like I don't even understand. I guess the difference between how I use it.
You're already 65.
So if you just happy with the chair for Daniela. You just come back to your seats or talk very, very quietly. And you want to hand it by hand or?
You can leave it that way so I can be free.
Yes, okay. So please welcome Daniela.
Hello, everyone. Good evening. Thanks for having me here today. It's a pleasure to be in this meetup. I'm Daniela Petruzalek. I'm a developer relations engineer at Google. And today I'm going to show you one of my passion projects, which is this diagnostic agent using ADK, Gemini, and OSQuery. So how this works. So first I will give you like a brief introduction. Why did I decide to do this agent? We're going to talk about Agent Development Kit, which is a framework for developing agents made by Google. It's an open source framework. What is OSQuery? If you never heard about it, this is one of the core of the system. And then I'm going to walk you through the evolution of this agent. I call her Ada. It comes from AI Diagnostic Agent, very creative. Probably in English that's wrong. Probably you should call it Ida, but I call it Ada. So bear with me. So I'm currently developing. I'm originally from Brazil, so if you think I have a weird accent, that's the reason. Before being DevRel, I used to be a backend/data engineer, so I was always into this software development field, one way or the other. And maybe I don't need to say this here because this is literally the AI camp meetup, but I'm currently obsessed with AI. And there's a reason for that, because I've been maybe 20 years in the industry, give or take, and I could not stand writing another CRUD API. Really. Like people are being like, talking about the doom. Oh, it's the end of software engineering. I'm saying, oh, thank God. I don't need to write another CRUD API, and I can make AI write it for me. So I was so bored, and this injected a new life into my career. So that's why I enjoy it. And if you cats, but let's go to the main theme. So space, the final frontier. If you read this, the abstract of this talk, I mentioned Star Trek, and I grew up watching all those sci-fi movies, Star Trek, but also other things like Minority Report or even Iron Man, and they all had this futuristic approach to interacting with computers, like moving in the space and talking with a computer. And I like to bring this here because for me it's kind of obvious that we're going in that direction, and it's not the end of software engineering. It's just a change in the way we perceive engineering. How do we work with computers changing? The interface is changing. But some people think that no, to be a software engineer you need to write code. No, that's maybe, yeah, you're a programmer, you're a developer, you're writing code, but if being an engineer is more than that, it's creating things, is connecting systems, connecting concepts. So it's much broader than that. And so when I started at Google, I had this challenge of ramping up because I had to learn all the things about Gemini and agents and so. And I had to create a project. And then I decided, well,
you know what, in Star Trek, they usually have this kind of interaction. Oh, computer, run a diagnostic procedure for me. And I say, maybe, yeah, can we do this today? And I start thinking, yeah, actually, we kind of can. So there's where it comes, agent development kits. Anyone here knows what ADK is? Have tried? So 1, 2, 3. Okay, not so many people. So yeah, I think probably there will be some things for you that know this platform, but for those who doesn't, this will be probably very interesting. So this is an open source framework developed by Google. It's, of course, because it's developed by Google, is optimized for the Google stuff like Gemini, Google Cloud, but it's also, it's open source and it's model agnostic. So you can use this with ChatGPT. Yes, you can. Can you use with a local model with using Olama and Quen? Yes, you can. Environment agnostic. Can you deploy this to AWS? Yes, you can. So it's kind of like, okay, if you're using Google Stack, it has some benefits because we had some, we know how these things work and connect together. But you can also deploy anywhere, all sorts of models. And the point here is, it abstracts a lot on how to create agents. So you have the definition of this is an agent, this is what instruction or system prompt, and these are tools you have. You don't need to worry about the low-level SDKs, all sorts of things. It's currently available for Python. Python is the most mature one, is the first one, but also Java and Go. Go was released last year. And TypeScript is brand new, like I don't know, it has maybe 1 or 2 months. It's the newest of the language, so you still not only have the framework, but you have the options to play with your favorite language. And the second element of this is OSQuery. OSQuery was actually a project that originated by at Meta, at Facebook. Actually, it was not even called Meta back then. And it's a tool to abstract certain operating system concepts as tables. So you can do like a query and say, oh, select star from processes, and you can see all the list of our processes running your machine. You can select star from memory info and see information about memory. So this is often used for monitoring dashboards. You can program some queries to run, every hour run this query, and then build those kind of, alerting systems and so forth. But here, yeah, this is just an example of one of the queries from process. And the thing is, when I learned about this tool many years ago, and I started playing with agents, I thought, you know what? I heard before that agents like LLMs, they are good at writing SQL. So if you pack this as a tool for the LLM to make a query, then I can have my computer run my diagnostic for me. So because everything about the OS is there. And that's how everything started. So the goals for this agent were kind of like this. Like, it's a generalist OS diagnostic assistant that answer questions like this ones, like, oh, why is my computer so slow? Or I'm having this mystical error, like too many open files. What's going on? Or maybe you want something more, I just want to know what are the processes that are consuming more memory in my machine? Or can you find something more abstract? Can you find any signs of malware? Like some weird processes and stuff. Or even the mythical, this is Star Trek, for Star Trek fans, the level 1 diagnostic procedure. In terms of architecture, the first version of what I developed was quite simple. So you as a user, you'll connect to a UI. This UI will call a root agent that's powered by an LLM model. In this case, I was using Gemini 2.5 Flash. In the demo I'm going to use, where I'm already using Gemini 3 Flash preview. And this root agent has access to this tool, which essentially is a Python function, like run OSQuery, that we call OSQuery, that connects with the OS and then gets the information. You can see that ADK is quite simple. Like this is the definition of the root agent. This is the entry point in terms of the agentic experience. And the things that you need to specify, like, okay, you have an agent. This is like a package you import. You're going to tell it model version, the model string you want, give your agent a name, and you have the instruction. The instruction is the system prompt or your system instructions. Technically, it's not the system instruction because the system instruction has the name and this instruction, but in essence is this. So here I'm saying, you're Ada, you're the emergency diagnostic agent, your mission is to do this, and you are, by the way, running on this operating system here. And you have this to run OSQuery. And how does the tool looks like? The tool is just a Python function that takes a query, and I'm running the OSQuery as a sub-process here. I'm asking it to output JSON just to be structured to parse if needed, but the LLM actually doesn't really care about this. I don't even need to do this. And just I take the output and return. That's it. And one of the things that I like to highlight in this kind of case is that this is I feel like it's my redemption arc as a developer, because I was always the one annoying that says you need to document your code, right? You need to document. And here, why I'm saying this, because what's important for the model here, the most important thing is this doc string, because the doc string tells you the model how it works. So the model will look at this and say, oh, actually, I need to pass this argument and I have this return value. So, and then by doing this documentation, you see even here, like there's very little code. The instruction is the most important thing. So, okay. So let's just run a quick demonstration here. I'm going to use UV run ADK web. ADK web is the development interface or developer UI. It's typically not the thing you're going to ship your agent with. Oh, I have a cache problem. Let's just delete browsing data and load it again. Okay, now we have the dev UI. So probably this is a bit too small. And okay, is it readable for everyone like this? Okay, so let's classic. Let's say hello. Oh, hey there, I'm an emergency diagnostic agent. Okay, please state the nature of your diagnostic emergency. Oh, please run. Let's start simple. A battery health check. On MacBook, the diagnostic for battery is a bit weird because there's a weird flag that appears. So I find it's an interesting thing to see. So, but let's have a look at this UI first. Here I'm doing the conversation with my agent, but this is development UI, so I have a few benefits that do this. If I click on the symbol of the agent, I can see the full request. I can see first the view of the event, but I can see also the request that was sent to the LLM. And here you can see that this is the actual system instruction that was sent. So it has my instructions and a few more things. In this case, it added this for me. The only thing that it didn't appear, I know this is kind of weird to see. Oh yeah, you are an agent. Your internal name is Ada. The description about you is that. So essentially, the system instruction is the combination of instructions, descriptions, and name. That's the only thing. But also it has all the tool declarations here. You say, oh, you have these functions, run OSQuery with this description. These are the parameters and so on. And the longer you are in the thread, the more items you see. Like you see these numbers growing up. Like so, I have a part. Let's say message 0, 1, 2, 3, 4, and this is going to be exponentially growing. So if I click on the last message, I can see the entire conversation here. And this is one of the things that most people don't realize when you start talking about with your agents and say, oh, it remembers me, it's my best friend. No, actually what happens is that the chat interface, they simulate this, because what they're doing is every time you send a message, you're sending the entire payload and saying predict the next message. And then the message comes back to you, you send another one. So you're adding to that trail and sending the full request again. The models are stateless, so just remember that. And this is how you interpret this kind of trace. Anyway, another interesting thing about this interface is that I can see the actual tool calls. So if I see this black box here, is the lightning bolt symbol there, is that the tool call is happening. The check mark is that the tool call return. So I can see that here. Let's have a look at the event, and it's basically sending this query, select health cycle count, blah, 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 from battery. This is the query that's sent to. And of course, if I can continue to explore here and see the outputs and so on. And this is the final analysis. Oh yeah, you have a weird alert here. And in this case, it's saying, oh, I recommend recalibrating the battery or blah, blah, blah. And this is completely bonkers. This is completely wrong. Because this battery is, this is a thing that on Apple Silicon Macs, they kind of deprecated this field and have other type of fields that does this kind of. So kind of is the typical challenge we'll face when the models are training with a certain sets of data and you have more up-to-date data and so on. Okay, so this is was the prototype. But then I start to ask this kind of question. Please look for signs of malware in my machine and own it, and then do this query. Select star from process where name equals malware. Yeah, the select is valid, is correct, but it's semantically wrong, right? No malware will name themselves as malware. So, okay, we need to improve this. We need to make ADA smarter. And a lot of the things, we talk a lot about context engineering, like the quality of the response, independent of the model. Of course, the more modern the models become, they will become smarter, but still, a lot of the context has a huge influence on the quality of the response. And one of the techniques to improve responses is called grounding. So when you add external data or current data to the response, to the context, so that the model can use that data to kind of replace or complement its internal knowledge. In this case, I had the hypothesis that I could minimize those problems by adding two things. So one is, even though OSQuery is quite an old project, so most of the data about it should be internal. They were trained on the source code of OSQuery because it's open source, but still, I didn't feel the models were quite precise yet. So I thought, okay, if we add some sort of schema discovery where it can discover the tables and description of the calls and so on, I think the response will be better. And the second thing is a query library. Why I keep reinventing the queries if we're probably, there aren't many queries out there that look for this kind of thing. Like a lot of 10 years of this project, the people already document a lot of those stuff. And actually, sorry, we are quite lucky because it's open source. The OSQuery schemas can be found in GitHub, and they are very nice just because they not only have the column specification, sometimes they even have sample queries and other metadata that is useful for the agent. And also there's the concept of query packs, which are curated sets of queries that people publish. And for the RAG itself, this data is very small. Like I just have a few hundred files. I don't need anything super clever to do this. Maybe I don't even need a RAG, I don't know. But I wanted the similarity search. But I decided to use SQLite RAG, which is another open source project. And just as an example, this is one of the tables. This is the full spec of the load average table. And you can see column, the things in bold are the ones that I really care about. The description of the table, the description of the columns, and a few query examples. Examples for LLMs are gold. This is, if you show this is actually how you do it, they will never get it wrong. And so yeah, and the benefit of RAG is that any of this text is valid to match, to compute the vector distance. And in terms of query packs, you can see something like this. Like, for example, there's a malware pack for every operating system, like for OS X, for Windows, for Unix, and so on. And here's just one of the queries that they have there. And you see they're way more complex than the simple select star. They have all this, I'm looking for these properties, and so on. So this is the base for my RAG. And the architecture is getting a bit more complicated, but bear with me. So I decided to do 2 RAGs just because SQLite, small database on file on disk, and one specialized for each. I thought it was simpler to do it this way. And in terms of using SQLite RAG is pretty basic. Like, you just need to create this SQLite RAG create. You create a RAG, and you need to ingest the files. It uses an embedder that's using Gemma. There's a Gemma embedding, blah, blah, blah. I don't know the full model string by hand. And you see the actual code that's doing the heavy work lifting here is this RAG add text, content, URI, and that's it. Then quantize vectors, close. RAG is done. There's 2 scripts, one for the query packs and other for the schema. And the actual retrieval function is very simple. Just I'm passing a bunch of terms, a platform. Platform is important because I don't want to have like a Windows query to anything my system is a Mac OS. And do the search and return. Same thing for the query library. Not much magic here. And what else is important? My root agent, since I added new tools, I need to update the instruction and say, oh, actually, by the way, you have these tools, use them. So, and if you can teach the agent how to use these tools, it's even better. So here I'm trying to be concise for the sake of slides, but you can be and say, oh yeah, if you have any doubts, using this discovery schema to find out the right columns and so on. So it can be a bit more precise than this. Don't take this as the ground, the best practice. But the important thing is you need to add this instruction. You need to name the tools in the list. Okay, so here, where's my ADK? Oh, it's so another thing, nice thing about the UI is like you see, I'm the same UI. I didn't reboot the server. I can just switch to my V2 agent, which is the one that has the RAG, and say, oh, please run a battery health check. It's the same query just for the sake of comparison. And you can see now it's already trying to use the query library RAG, and you can see it called here. Where is it? Here. Just up. So platform Darwin, search terms, battery health, top 10 queries, and so on. And I can see the RAG results in this call here and say, oh yeah. I'm not going to validate this response here, but see, added a bunch of results here, platform NFV run. Not sure if this makes any sense, but yeah. So there's a bunch of response, and it will use to construct the knowledge about the query. So you see, and the response is still wrong because it's still complaining about the check battery. And what's the problem here? I gave a lot of internal knowledge to this model, but it doesn't have access to the external world. Like this could be probably solved with a Google search call, right? If it was just able to say, oh yeah, actually I'm going to Google search check battery and see what's going on with this kind of machine. So this is why the next step in the evolution of Ada is to actually add other tools, for example, Google Search. And this is one of the nice things about ADK that becomes built in out of the box. So Google Search, code execution, you can have like enterprise search if you have vertex AI search, BigQuery, other tools. If you are on Google Cloud, those most of them come out of the box. There are a few catches here. Is that only one built-in tool is supported by agent? Like, for example, code execution is like a sandbox environment. The model can generate some Python code, it will run, but you need to have like an environment, like a special environment to do this. You cannot add a code execution tool with my run OSQuery tool. You need to have separate agents to do that. And there's another rule, and this is it's kind of an API problem, that API compatibility problem, that you cannot mix search with non-search tools. So I cannot mix Google Search and run OSQuery in the same agent. But and I can make agents become tools. So there's a small hack here. This one is for Google Search. So I created a special agent that only does Google Search, and you can use this agent tool type to convert that agent to a tool that can be called by an agent. So essentially, it's a bit a hacky way, but the root agent will have the search tool, and the search tool is an agent tool that calls an agent. Okay, so yeah, not ideal, but things we need to do sometimes. And again, update the system instruction, search tool, and we're done. And in terms of design, I'm just throwing in the diagram yet another tool here. And let's see if this behaves better. Sometimes it does, sometimes it doesn't. It's still, because this is just a prototype, I didn't try to fine tune that much. Please run battery health check. Sometimes it will do the right Google search, sometimes it forgets to do the Google search. It really depends. So this is one of the problems with agents, that they're not deterministic. Takes a bit of, oh, wait, I'm seeing a Google search call. And in this time, yay, lucky. It did check, oh, what's check battery in macOS? Let's see what Google responds, because also we depend on Google search returning the right thing for us. And what does it say? In context is often the result of reporting discrepancy. Yeah, okay, so this is the right answer, actually. So it's basically saying, oh, it is normal. So that's one of the benefits of, like, yeah, when you talk about grounding on search, you can get this up-to-date information. If I was doing like a malware investigation, I really want to ground in search as well, because probably those malware definitions are very old as well. Things like that. So if you're like me, you probably are thinking that this is kind of getting a bit messy, right? Because I'm throwing one root agent with all sorts of tools, and it kind of like, it becomes the blow, like it becomes like a monolith, spaghetti monolith kind of thing. And this also happens with agents. So one of the things that ADK help is you can also have different patterns of agents. You have what we call workflow agents, like sequential agent, parallel agent, loop agent. And you can use them as building blocks to combine them. For instance, a sequential agent it will literally, as the name says, it will just run agent A, agent B, agent C in order, always in the same order. They're deterministic. They are not powered by LLMs. Like parallel agents will fire all those agents in parallel at the same time. Loop agent is an agent that you can say is same as sequential, but you can say, oh, run this 3 times, or run until this condition, for example. And of course, the basic type is this LLM-based agent. So a slightly maybe better design or not could be something like this. I have a root agent that doing my triage, and then I send to a specialized diagnostic pipeline. I don't know how I'm on time, but I'm not really going to demonstrate this one because this also tends to be slightly slower because now I need to do handovers between different agents. But just to show the code, so I have something like this, like the planner, the investigator, and summarizer. The diagnostic pipeline just has a name and sub-agents with those three, and they will run in the exact same sequence that's there. So first planner, second investigator, third summarizer. And then for the root agent, you just need to change the sys instruction to say delegates to the agent. And instead of passing a tool, you pass this thing as a sub-agent. So now we have the power to delegate. And the thing about sub-agents is that you lose control. Root agent is not in control anymore. Now it's responsibility of the other agent. So actually, yeah, let's do a quick one just to show this before. Please run a level 1 diagnostic procedure just for fun. So what you're going to see different is this kind of transfer to agent event, which is say, and you will see that all those agents, they have different colors here. Now this agent is Ada, this agent is the planner. And this is a visual way to know the transition. So the planner sent to an investigator, the investigator is working on it. And say the planner is this. Oh yeah, level 1 diagnostic, I'll do 1 topic, 5 queries. This is something I customize the prompt to say, oh yeah, if I say level 1, just run 5 queries. I say level 2, run 10 queries, just to make things simpler. And say, yeah, the investigator came up with this report, and then I have a summarizer that maybe I just want this as a final output, and I don't want the full details of the plan. For example, if I have my UI, which is the next and final step to the puzzle, the client interface. So the thing is, up to now, I'm using the dev UI, and the dev UI is amazing for devs because you don't want to ship this, right, to your clients. So what you need to do is, of course, you need to create your own front end, but also you need to play with something that's called the runner. And the runner has a few responsibilities. One is to control sessions. So if you want to have a persistent session, and here I'm using the in-memory session because I don't care. If I close data and turn on again, I don't persistence, but you can have like this stored in a database or somewhere else. And the runner is the one that will be generating the things for the UI. So here, like I have a chat handler. Well, chat handler, I'll send receives a query from the front end, and we'll create this stream generator that will start streaming the responses back. And here I did a small front end. This was inspired by a tweet I saw a long time ago. But as I told before, I like anime and games and cute stuff. So this is why I created Ada with this interface. And I can say, this is, yeah, please run a level 1 diagnostic on my battery. Actually, let's do level 2 for now. So, no, level 1, I don't know. And then she thinks, and when she gets a response, she gets in speaking mode. And here you can see the log window. So it's just, I added, because the pipeline is kind of slow, I added some logic that if it's a simple query, call the fast diagnostic agent, which is exactly the same as the initial one. But if it's now run level 2 diagnostic, then in this case, it will say, oh, yeah, this is more complex. So I'm going to send to the full reporting pipeline. And here you can see the planner output, and I can expand this and see, oh, this is the actual plan, and so on. And I use this interface to also experiment with different models. In the actual open source project, I have a button over there that says, oh, answer this with Quen, answer this with a Gemini, or answer this with a GPT, and you can compare the responses. It's kind of interesting as also to see how different models behave. Anyway, you're already bored hearing me. Everyone wants to go home and sleep. So these are the final words. There's a lot more that can be done with ADK, and the news is that ADK makes this very easy to do. Like memory session control. Maybe I should use a loop agent to try to iterate and refine those reports first. Add more tools. Maybe you should run shell commands, or maybe not. This is kind of dangerous. So I don't know. Oh, you need to free your disk space. Let me run rm-rf for you. So if you enjoyed this, I write my blog, daniela.dev. You can see all the talk materials and events I share on the daniela.dev/events. A few socials, and thank you very much. I'm not sure if there's any questions.
I have a question. Like when you define the different tools and the different agents, like is there a way to have like some kind of ranking of which ones you trust for any given task? Like web search by return something that's rubbish, whereas your rank might be more grounded, more factual. Like is there a way to argue with stuff like that?
I think you can basically give this kind of details in the prompt itself. So here, for example, now showing how the things are done. So yeah, here I'm adding some stronger directives, like for all tasks, first use search query library. So I'm putting a strong emphasis on this one because these are pre-made queries, so you don't need to discover. But maybe, but if you didn't find one, then use discover schema to try to find something appropriate. So you can play with the prompt, adding this kind of workflows or guidelines. Like I have also a greeting protocol, reporting protocol, this kind of thing. I think will help you. And you really want to have more control. One of the things you can start creating specialized agents that only do that too, and say that then they don't have much option. Like I don't know, like the kind of like the Google search agent, but that's for a different reason. I had to do that way, but you could also do that.
MCP, I guess, is another framework. How does this do you come the MCP on the front of it, or is it competing? Again, I think OpenAI has a similar framework, so I'm just trying to get a sense of the frameworks, how it works.
Yeah, they do. Like OpenAI has a. I'm trying to remember the name. It's literally something agents. I forgot the actual framework, but MCP is not an agentic framework. MCP is a protocol to create pluggable components for models. For example, here I have a hard-coded definition of run OSQuery, which is my tool. But and if I do this way, if I decide to rewrite this in Go, for example, I need to rewrite this again. What I could do is expose this as an MCP tool, and then the same tool can be consumed by both agents. So MCP is this kind of protocol that allows different clients, and ADK is one of those clients. Actually, ADK supports MCP, but you could plug in on VS Code, you could plug in on your IDs, and so on. Yeah, and MCP is not just about tools. It has other concepts as well, like prompts and resources. But the idea is to create these units that you can transport to different, like it's kind of like a reusable component for LLMs.
So do you have a lot of ready-made tools? Is there a directory of tools you can use for this agent?
So
just plug in, as it were.
Actually, ADK, so built-in tools. in the case of ADK itself, it does have a bunch of like a whole repository for tools you can use, like the built-ins I mentioned, plus a bunch of product tools like BigQuery and so on. And you also, literally anything that has been exposed as MCP can be used. And it also has LangChain support, so you can use like a LangChain agent in your together with ADK. So it's very flexible in this sense. One more.
So if you're in an enterprise environment, you're creating some agentic system for the use of lots of people. Does this support, identity management, passing identity down the chain of agents?
It does. I confess that I haven't played with it because of my role, I mostly do demos. But it does have like ways to do OAuth and other types of authentication. Yes. Yes, we do. Yeah, I know it's a bit tricky, but here even in the dev UI, if I just click here, let's see, you have a last tab that is the eval tab, which is not showing here. Oh, I need to just refresh this. I think, oh yeah, it's not showing because I killed the process. I'm using I need to run ADK web again. So you can create some, it's cache problems, cache invalidation problems. Let's refresh this, eval. You see, I can create an evaluation set, and this will be, you can add, based on this query, I expect this kind of response. And you can configure like an evaluator. Usually you have different types of evaluators. One then is like LLM as a judge. You can use a different model to evaluate. Is this a good response or not a good response? Yeah, but if you want something that's deterministic, you can specify some criteria and have functional scaling and say, did you... it really depends on the agent, actually. In this case, because it's a diagnostic agent, if I wanted the evaluation set, I'll need to simulate a problem in the operating system and make sure the agent will find the right solution. So it's kind of hard to create this without mocking the entire environment.
Would you get like create evals to like have the OSQuery as the output instead, like something like that?
I initially thought about this because, but actually no, because for example, if I say, check my battery, maybe that's trivial that you need to do select star from battery, but not always. I had when I put those questions here in the beginning. Whereas these ones, actually, all of them I had to use Ada to solve. I was playing with a different tool, and I was having this too many open file error happening a lot in this machine. And I said, you know what? I'm going to use Ada and see what it says. And actually, it found the problem. Actually, the problem was not file descriptors; was the disk was full because I had a rogue process that was filling the disk. So I don't really care about how it came to that conclusion. So do I care the sequence of tables in which exact queries it run? No, but I care about the conclusion. So you see that the problem in evaluating is that. So there are many paths to come up to that conclusion. That's the kind of thing. Anyone else? Are we good?
Oh. I mean, you're saying it can take multiple paths to arrive at the same conclusion.
Yeah. Because it's an operating system concept. So sometimes you have different ways. Like maybe you'll find this problem with the system log. I just look at the system log table. I didn't need anything else. Or maybe, no, I'm looking at the processing memory and I see that this thing is happening. So yeah, it's kind of, or I'm looking at swap information. They have this thing is doing lots of swap, so it's probably writing a lot to this. I don't know. It's kind of crazy, but you can have different
cause analysis.
Yeah, at the end you should get to the same problem, but you probably the investigation path is not linear.
I really like the front-end design with the animal character introduction, like not this type, or make buildings.
The front end was basically, it's not pretty. The under the hood, it's essentially a bunch of JavaScripts. Here, and by the way, I haven't written a single line of this code. I'm not a JavaScript developer. This was entirely vibe coded. But it has a bunch of JavaScript, and it has like it's basically HTML and JavaScript. So this is the template page, and it serves us as a Python. It's a REST API endpoint that serves the index. So, and for the animation, I have a bunch of assets that either in different positions. I have the idle position, I have the talk, and I just add a bit of random delay to, she's talking. So to not become mechanical, I added the random noise too.
To be more specific on the question, what you used to build, you said you might code it. What tool you use?
Oh, that one I'm using. So I have anti-gravity was not a thing. Actually, this is me during the previous talk. Sorry for that. I was actually doing some tweaks. So I'm using what's called the Gemini CLI. Loaded. So yeah, Gemini CLI is my default tool for that. And but now that Google released anti-gravity, I'm also using anti-gravity. So I tend to, if it's something more terminal-based, I tend to use Gemini CLI. And if something more, I don't know, web-based or more complex application, use anti-gravity. But I found situations where Gemini CLI work better and anti-gravity work better. So I tend to start on one and finish on the other, just so they can fix each other's mistakes. But yeah.
Thank you.
Nice. Okay, very good.
Last question. Excuse me. Have you wrote any rules for the queries, like for the LLM to follow? For example, when a user asks like specific photos are sensitive, is there any like rule restrictions that you place?
Not in this case, no. I didn't add any, but you can add some deny rules if you want. You can play with the system prompt, or you can add some. There are, I'm trying to remember the exact name, but you have like some pre-processing hooks. You have post-processing hooks you can use to also filter out some answers or do some processing if you need. And in the not on ADK but Gemini API, they have some filters for I don't know. I don't want adult content, or I don't want cursing. I don't want some language filters. You can do that as well. Okay, thank you.